3C-2. Shh, boys. Hey. Hey. Levi. My turn. Thank you. Okay. Identifying real-world key features from real-world problems. Okay? All right, so what we're going to do is we're going to do similar to what we just did. We got to get an equation from a word problem, and then we're going to graph it. Okay? We're going to graph it, and then we're going to talk about what it means on the graph. So it says Meadows started 8 feet away from a motion detector and walked towards the motion detector at a speed of 1.5 feet per second. Graph Meadows' distance from the motion detector as a function of time, then identify the key features of this linear function. Okay, so let's go back through. All right, so what's happening in this problem? Somebody, anybody.
She's moving. She's walking.
She's walking to the metal detector. Or not the metal. The motion. Sorry. We were just talking about
the metal detector. She's suspicious.
Okay, listen, boys.
I'm sorry.
She's walking towards the motion detector. Okay, so let's think about this. She starts 8 feet away. She starts 8 feet away, and she's walking towards it. So is she getting further or closer to it?
Closer.
Closer. Okay. All right, so Meadows started 8 feet away from a motion detector. Any keywords here?
Feet.
She started 8 feet. Stop. Okay. What's another keyword? Just in this part. Meadows started 8 feet away from a motion detector. Started is initial. So 8 is what? That means initial. That's my B. That's my initial value. So that's my B. Okay. And walk towards the motion detector at a speed of 1.5 feet per second.
1.5 feet per second.
So 1.5, guys. What's another keyword?
Per second.
Per means what? X. Okay. And she's walking which way?
Right.
Towards it. Okay. So is her distance getting further or closer? Closer. So is she going a positive 1.5 feet or a negative 1.5 feet?
Positive. Negative. Positive. Negative.
Is she moving closer or further?
Closer.
She's moving closer. So her feet away from it is getting smaller. So it would be negative because the distance away from the motion detector, the distance away from it is getting smaller because she's moving towards it.
Oh.
So it's subtracting 1.5 feet every second.
So it's like the opposite way, I guess.
Okay, so this should be a minus 1.5. Okay, we're going to start with E. Y-intercept. What letter stands for Y-intercept? B. What is my B? A positive 8. Okay, slope. That's my M. What's my slope here? Negative 1.5. And how do I write that as a fraction? Because it's slope.
Negative 1 over 5.
Okay, so if I want to, remember, do this with me. Shh, stop. Stop guessing. Do this with me. Go on your calculator. I want to transport, do this with me because you guys don't know how to do it. I want to go from negative 1.5 to a fraction. So negative 1.5. Then what?
You do menu.
Menu.
Number.
Wait, is that negative?
Yes, number.
Approximate subtraction.
And enter. And what is it?
Negative 3 over 2.
Okay, so negative 1.5 is negative 3 over 2. Why did I do a fraction?
You can graph it.
Because we're going to graph it. Good. Because you're going to graph it. Okay? All right. How do I write, what's function mean? An equation. I'm kind of skipping around. Just stay with me. So can I write an equation from my M and my B?
Yeah.
Yes. Equals. Now you can do a decimal or you can do the fraction. Let's just do the fraction. Negative 3.2 or 3 over 2 x plus 8. Y equals mx plus b. Okay, now we're going to graph it. So before I graph it, focus right with me, okay? I need to label my axis. Okay, so this is x, this is y, in words. What is the x values talking about? What is the x talking about? Per second. So my x-axis is going to be talking about seconds. Seconds. Right with me. Right with me? Okay. My y-axis. Okay, my y-axis. What's my y value talking about? Feet what? From? So feet away from the motion detector. So my y-axis is going to be talking about feet.
Please shut the door.
Yeah, that's annoying.
Go ahead.
Jillian. Cool.
Quickly.
Or take your time, little time.
Okay, now I'm going to be graphing this. Do I know? Do I know the x-intercept right now?
No.
No. I have to graph it in order to know that. Okay. So, how are we going to number this? How would I number the seconds?
One.
By ones. 1 second, 2 seconds, 3 seconds. Do it with me. 4, 5, 6, 7, 8, all the way 9, 10, 11, 12, 13, 14, 15. How would I measure the feet?
Same thing.
Where did I start at?
8.
8. So I need to measure by how many?
2.
No, 1.
I would do ones. 1, 2, 3, 4, 5, 6, 7, 8.
It goes with 10.
Oh yeah, 9, 10. Okay, so she's moving towards the motion detector.
No.
So is her feet going to be going up or down?
Yeah.
Down, because she's moving towards it. She's getting less and less further away. Okay, so if I'm going to graph this, where do I start?
At 8.
At 8, my y-intercept here. What's my slope? So am I going to go up or down?
Down.
Down because it's negative 3, then to the right 2. And do it again. Do it with me.
The negative 3, 5. Like this.
Okay, I can't go any further. So draw your line. Okay. My x-intercept. Does it go perfectly through an x number?
No.
No, there's not a dot on the x-axis. So how do I find my x-intercept? Okay, if I had the ordered pair of an x, the number would go in the what spot? The x spot. 0 would go in the what spot? Y. So what could I do to find this x? I know what the y is going to be. Y has to be 0 if it's an intercept.
Wait.
Okay? So if y is 0 for an x-intercept, what could I do to go find the x?
Where the arrow?
Boys.
How?
Just throw the left thing, I'm sorry.
So if I know the y is 0, what could I do to go find the x?
Wait, doesn't it technically cross the X though?
It does, but it would be a decimal, and I don't know the decimal.
Or no?
It doesn't perfectly go through a corner. Okay, I know the y, but I don't know the x. So could I take 0 and plug it where? In the y spot. And then what?
Solve.
Solve for x. So I'm going to take 0, plug it in the y spot, and solve for the x. Do this with me. Levi, stop, please. Right with me. How do I solve for x? Minus 8. Am I solving by myself?
No.
Where's your pencil?
Give it.
Okay, so negative 8 equals negative 3 over 2x. Now what? Divide by negative 3 over 2. X equals?
16 over 2.
Decimal's fine.
5.3 repeating.
Let me see.
Yeah.
Negative 8 divided by negative 3 over 2. 5.3 repeating. So I'll just say 5.3 is fine. Okay, so what's my x-intercept? 5.3, comma, 0. Questions? Does that look about right?
Yeah.
Yeah, it does. Okay, number 2. All right, Jaden's going on vacation with his friends. His parents give him money while he is gone. His initial amount from his parents is $250. On average, Jaden spends $35.25 each day while on his trip. Graph the amount of money Jay spends each day as a function of time, then identify the key features of this linear function. Before we start, I want you to change this to just $25. Just $25. Okay, everybody change that? It's going to change up the problem a little bit, so make sure you just make it $25. Huh? I crossed out the
Oh my god.
period.
Don't be quiet.
Okay, $25. All right. So what is happening on this? Jaden's going where?
Vacation.
On vacation. What else is happening?
He's spending money.
He's spending money. How much?
25 each day.
25 each day. Okay, so it says Jaden's going on vacation with his friends. Does anything in this sentence help me write an equation? No. His parents give him money while he is gone.
No.
His initial amount from his parents is $250.
Initial amount.
Initial amount, that's my what?
You're starting.
My starting, which is what letter? B. Okay? On average, Jaden spends $25 each day while on his trip. So, $25, what else is important? Each, what does that mean? X. One of y'all are about to move. I said one of y'all are about to move. Okay, I'm going to go out of order again. What's my y-intercept? That's B, which is what? Is that a positive or a negative 250? Positive.
Positive.
Okay, my slope, that's my M. What is representing slope?
Negative.
Why would it be negative?
Because he's spending.
He is spending it. He starts with a positive 250, but he's taking out $25 each day. So negative $25 is my slope. Okay, can I write an equation? Yes, what would my equation be? Negative 25x. Make sure you're writing with me. Plus 250. Can I know what the x-intercept is? What do I have to do first? Graph it. Let's graph it. Graph it first. X and Y. Okay. What is the x's talking about? X what? Each what? X is talking about Days. So how should I count the days? By ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Make sure you're doing it with me. Right with me.
No, sorry.
Okay, what's the Y talking about?
Money.
Money. Total money. Okay, now, my Y-intercept is what?
It's 250.
250. So
So-
what? Can I count by ones?
50s.
No. What should
No.
I count by?
25.
But look at my slope. My slope is what? 25. So I'm going to count by 25. So 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. Okay, where do I go on my graph? What do I start with? B. Where do I put my dot?
Very top.
At 250 on the y-axis. Now, what's my slope?
Negative 25 over 1.
Over 1. So I'm going to go down how many?
25.
But how many is it counting by?
25.
25. So I'm really just going to go down 1 because it's counting by 25s. Then my run is going to go over how many?
1.
1. Now these are counting by ones. So I'm going to go down 25 over 1. Everybody with me? And do it again. And draw your line. Okay, what's my x-intercept?
10, 10, 10, 10, 10.
10, 0. Do I have to plug it into the equation? No, not this time because it actually falls on the x-axis. A dot falls on the x-axis, so I know the x-intercept. This one, the dot didn't fall on the x-axis, so I had to go find the x-intercept. With me?
Yes.
Okay, any questions?
No.
All right.